everyone, welcome back to today's episode of Quantitative Data Analysis, Chapter 4. So we're going to be covering typical values in a group, otherwise known as measures of central tendency, otherwise used in common language as averages. All right, just a brief overview before we get into the Stata portion. You hopefully have already looked through this information. But measures of central tendency are everywhere. Normal people don't call them that, but they are used in daily life all the time. So it's really important that we understand what these different measures are telling us and when one is preferable over the other. So median home value is a very commonly used measure to talk about how expensive housing is in one area versus another area. Notice that it's median home value and not mean home value, and we'll talk about why that is. Average household income. I use the word average very broadly here, which can be really misleading. If you're talking to a statistician, you never want to use the word average. They'll say, are you referring to the mean or some other measure? The word average is often used to refer to the mean specifically, which is also a measure of central tendency. Batting averages in baseball are simple averages, or so I'm told. I have no idea about anything about baseball, but I understand batting average is a very simple measure of a central tendency. And GPA, you use it all the time. You're very familiar with it. What is it? It's a summary measure trying to summarize a lot of data in one number. So there are three measures of central tendency. We just talked about two of them, the mean, the median, and also mode are all measures of central tendency. You've probably covered these at some point in your schooling, but we're going to talk about them more specifically within a social science data analysis context, so that you can figure out what the pros and cons are of each one, what type of data each one is appropriate for, and most importantly for this tutorial, we're going to figure out how to get this information out of Stata. Okay, so measures of central tendency help us describe the typical value for a variable. If we were to look at median home value across the entire United States, that's a summary trying to summarize what housing costs in the United States, looking across hundreds of thousands of homes that are for sale, maybe even more than that probably, across the entire United States. So it's one single number that's trying to describe probably a much broader phenomenon. And that has pitfalls, which is why in the next chapter we're going to also cover dispersion around a mean or around a data distribution around a center point in a variable, because just looking at the center point doesn't tell us the whole story. But we'll leave that for the next chapter. So in this chapter, we're talking about finding a single number that describes a typical value. That can help us assess whether the value of a particular case is high or low. And values that are less than the typical value are considered low, and values that are above that typical value are considered high. So, for example, I might want to know, how is my income compared to other people in my field, for example? For a professor of sociology, do I make a lot of money or do I make a little money working at Chapman? Or for a professor in general, compared to all professors at all universities in all disciplines, do I make a lot of money or a little money? I'll give you a hint on that one. I know in which direction that one probably goes. But for a sociology professor, I probably don't do so bad working at a private university, right? But that's what finding a typical value allows you to do. You can compare a case to the typical value. So how baller are you compared to your dorm mates? I don't know, however you decide to operationalize baller. Maybe it's in terms of income. Maybe it's in terms of, I don't know, the type of car that you drive. But you need to be able to describe what is typical in the group in order to compare a case to that. And then we'll talk about these other examples in more detail later. So let's dive right into Stata. So for Chapter 4, we're going to be using the 2016 General Social Survey. Again, I'm going to that folder where all of the data sets for the textbook are found, and I'm going to open up General Social Survey GSS 2016.dta. For me, remember, it's open with Stata 15. I finally remembered. I think it took me 4 tutorials, but I finally remembered to right-click. You can probably just double-click on the data set to open it since you don't have 2 versions of Stata running on your laptop. Okay, and so we have our familiar and beautiful Stata layout here with our variable window on the right-hand side, the command window at the bottom, which we're really not going to use too much because we're going to go straight into our do file. So let's go up to the Window tab, open up a new do file, which we're going to use for Chapter 4. And we've already opened up the GSS 2016. You can see the variables have been added to the variable window. We always want to start our do file with a comment telling ourselves what we're doing in this. So as a reminder, when I open up this do file, I'll see, oh, this is a Chapter 4 tutorial. And the very first thing we always add is this use command and the full file path for our data set so that we know which data set we were using here. And if you've copied and pasted it correctly, use should be in blue and the full file path enclosed in quotes should be in red. And it has the data set name at the very end, GSS 2016.dta. All right, so we're ready to begin the tutorial. If you're a compulsive saver like me, you might just start by saving your do file immediately. We can call it Chapter 4.do and save it in the same folder where we have our tutorial data sets. All right, and let's just become a little bit familiar with our data. First of all, we've used the GSS, I believe we used this very same 2016 version in one of the previous tutorials already. It has lots of variables and lots of observations. Do you remember how to find out how many of each? Browse. Good job if you got that right. So we can type in browse. We highlight it by double clicking or clicking alongside the line that you're trying to highlight and then clicking on execute selection, do. And that opens up the data browsing window. And at the very bottom, we have 2,867 observations. So we'll see these rows are numbered and each of them is one of our survey respondents, and there are 2,867 of them if we scroll all the way down. And how many variables? 983. Whew, good luck going through that list by hand. And again, whew, thank you, survey respondents who answered these questions, because I'm curious what the average amount of time it took to complete this survey is. I wonder if that's sometimes even included in the survey. I'll have to look that up and see if it's in the GSS. Anyhow, so each of these survey respondents has responses to probably not all 983 questions, but a lot of them. So we can see this is respondent 1. Respondent 1 was asked about the marital status and probably of people in the household. It looks like they're asking for multiple people within a household. So we don't know exactly what this is because our variable label is only marital status of 10th person, but we're like, okay, what does 10th person mean? So we would probably want to open the code book, the actual GSS PDF code book, and look at the variable definitions, the full variable definitions, and often it gives you the code book will even give you the wording of the question. So as an example, do you think the use of marijuana should be made legal or not? Is the question that was asked, and that has a particular variable label, and that's called grass. That's an odd variable label. So we would be looking for the variable grass, and we have to look to the code book to find out that that question was asked this way. Do you think the use of marijuana should be made legal or not? Actually, just for funsies, let's see if we can find variable grass in our data. Yes, we can. So the variable called grass is here, and the label should marijuana be made legal is here. Actually, this is a very good variable label compared to these marital status of these many people, which we have yet to answer, but I digress. That's not even what we're focusing on in this tutorial. So let's get back to the data at hand. What are we interested in doing in this tutorial? We're going to look at social media use. This GSS data set asked about social media use for 11 different websites: Twitter, Facebook, LinkedIn, Snapchat, Tumblr, WhatsApp, Google+, Pinterest, Flickr, Vine, and Classmates. I have no idea. I've never heard of Vine. Classmates? I don't think I've heard of that either. Flickr? Isn't that like a photo? Anyways, so in any case, we're going to try to figure out how common is social media website use in general, particularly for these 11 websites. So we can see that there are specific separate questions for each of these. Twitter has its own variable. Flickr has its own variable. Google+, who even uses Google+, has its own variable. So these 11 websites have their own separate variables, which makes it really hard to get a summary, single summary measure. So the first thing that we want to do is actually create an index that sums up the responses to each of these single variables. Let's just quickly look at these single variables. I'm going to run a one-way crosstab for these 12 variables. Twitter to, Facebook to, LinkedIn, Snapchat. I'm going to be really shocked if I'm able to type all of these out without any spelling errors. See, there we go, like Pinterest. It's going to confuse me. Okay. Flickr to, Vine to, almost there, and Classmates, no A. All right. Notice a lot of these variable names are abbreviated, highly abbreviated. That's because you want to limit how long your variable names are generally. In Stata, it only allows, I believe, 12 characters, and it'll cause problems if you try to go longer than that. So a lot of times we have to use short abbreviations for variable names. All right, you'll notice I highlighted and executed the line, the tabulation, and I have now summaries for each of these 11 variables. You can see for all of them, the total responses are 13. Oh, nope, there we have one with 1373. So we have approximately 1,372 or 3 respondents on these variables, and they're all coded 0 or 1. Either you don't use and are not registered on the website, or you are registered or you even use it regularly. For a particular website. So what we want to know is how many of these 11 websites do people use? Do you remember what to add to the end of this tabulate command so that we can see missing data? If you remembered, kudos to you. If you remembered, it's comma missing or just miss. So I'm going to rerun this. I highlighted and I used Control-C to copy and Control-V to paste. And now I've rerun the tabulate command with the option to show the missing data on each of these. And this gives us some really interesting information. It actually gives us 2 types of missing variables. But for our purposes, those are fully missing. So here we'll see that there were a total of 2,867 people included in the GSS 2016 survey. And of those, we have these respondents, so the 1,300 and some odd respondents to the question, and then some of them that were not asked or refused to respond on a particular question. And so when we add up the responses to these 11 questions, we're going to make sure to include this missing option so that people who weren't asked the question at all are still set to missing. All right, so how do we create this new variable? We're learning a new command now called egen. It's an automatic generate command. So you think of the generate command that we used previously with generate and replace, or generate and recode. Here we're using extension to generate, which is egen. And there's a quick way to add all of these 11 variables up using egen. And we're going to call the new variable social media. So we're saying generate the new variable called social media and make it equal to what's called row total. That is, sum up the total for these. And I'm just going to copy and paste these 12 variables here. So you enclose the variables that you want to create the index out of in parentheses, and then add the missing option to make sure you have data that was missing previously on all 11 items to be set to missing in the new version of the variable. I always tabulate the new variable just to see what I've done. So this new variable now is the sum of these different 12 social media accounts. So here we can see how many people responded that they use 0 of these 11. 159 people, representing 11.5% of our sample. How many people used 1 out of the 11? Nearly 20% of the sample, 271 people. How many people used 2 of these 11 websites? Actually, I wonder, let's see, I'd be like at Twitter, Facebook, LinkedIn, I never use. Have it. Oh, I have it, but I never use it, so I would have responded 1. So I'm probably like 4 of these 11. That's embarrassing. And then we can see most people are right around this 2, right? 1, 2, or 3. And then there's like a few people who are on all of them. Hopefully they're not regular users. Talk about social media addiction here. And we've got some people that are like totally disconnected. Who knows? They probably live in the forest. How did they even end up in this sample? But are part of 0 of these 11. Or maybe they're really old. We could actually test that by looking at the average age based on the number of social media sites they're on. But I digress. We're not going to do that now. What we want to do now is figure out what's the average, and we're going to get all 3 measures of central tendency: the mean number of social media sites that people are part of, the median number, and the mode. I'm going to go a little bit backwards here because I already have it pulled up. The tutorial does the mode last. We're going to do it first. The mode is right here. It's the value that has the most responses. It's a single value in the entire range of data, our range of data being 0 to 11. So people could have reported between 0 and at most 11 social media websites. And what's the most frequently occurring response out of all of these? Well, 25% of our sample reported that they used 2 sites. All of the other frequencies are lower than that: 19.7, 19.5, 11, so on, decreasing on either side. So the mode is actually this number 2. So the modal number of social media websites that people use is 2. That was actually easy, right? It's within the tabulate command. It was only easy because there's a clear winner here. If we had 2 values that had 25% of respondents reporting using those, then we would have what's called a bimodal distribution. And you should have seen that in the slides as well. Okay, so let's move on to the median. The mode is not used that often in social science research. You will almost always see either the median or the mean presented in research papers, even in newspaper articles and so on. So we're going to pay more attention to those two. How do you get the mean? One easy way, and we've already done this, is to use the summarize command. Summarize social media. And that gives us the summary statistics here. We see that the mean number of sites that people are a part of is 2.4, almost 2.5. That's pretty close to the mode. But there is additional information here, which we'll talk about more in depth in the next chapter, that's really useful and informative. Yes, the mean is approximately 2.5, but people vary pretty substantially by about 1.5 or over 1.5 social media websites. So a lot of people use almost 4 social media websites on average, but also a lot of people use approximately one. So above and below the mean is also pretty common. And notice that the mean itself, no single person uses 2.5 websites, right? There is no option for that. You either use 2 or you use 3. So the mean can be a value that doesn't even actually exist in the data itself. The other thing that we see here, excuse me, I feel like I've sneezed through every tutorial. I must have some sort of like allergic reaction to videoing these tutorials. Okay, so we also get the minimum and the maximum values in the data, which tells us the range of responses. What did at least one person report using 0 websites? Yes. And did at least one person report using 11 websites? Yes. So that's the range of our data. And these measures tell us something about, again, dispersion around the mean, which, again, we'll talk about in more detail later. So we can get this information, this mean, in another way. I think it's a more cumbersome way. I would like to just have this summarize information because it gives me all of the things that I care about. But if we wanted to go straight to just getting the mean without having the standard deviation and minimum and maximum, we can use tab stat command and specify that we want the mean to be the statistic of interest. And if we run that, it'll give us just the mean. Why would we do this? Well, then we can easily replace that mean with the median. And now we can see that the median, which Stata also reminds you is the 50th percentile, is 2. And this number does exist in the data. So how did Stata come up with this median value as 2? Well, the definition of the median is that 50% of your data points, so of these 1,373 respondents, 50% of them reported a number lower than the median, and 50% reported a number above. So the median is that number at which you split the 1,373 respondents in half. We can actually find that by the cumulative percent, and we see that that number falls at approximately 2. The median has to exist in the data distribution, so the median would be 2 in this case because 50% of the data fall below 2 and less than 50% fall above it. But the 50th, so again, median is the 50th percentile, meaning 50% of the data fall at or below this number. All right, so we've now discovered how to get the mean and the median. Gives you the, oopsie, median, which is the value that 50% of the respondents fall at or below. All right. So I'm going to go ahead and save the do file. So we've learned how to get the mean and the median, and we got the mode. Can ascertain the mode by finding the most frequently occurring response, in this case 2. Wait, what was it? Was it 2? No, I already forgot. It was 2. 25% of respondents reported 2, and there's no other percentage greater than that. So that is the modal response. All right, see, I'm a compulsive saver. I can't help myself. So let's move on to the last couple of commands here, which are, actually it's the last command. The last command will create a new, last two commands will create a new variable called social media mode. So we're using eGen again. This time we're creating a variable that contains the mode of social media for everybody in the sample. We're going to set all of the cases to have the mode value. So we should expect that everyone in the data set is going to get a number 2 when we create this variable. And we can tabulate this new variable to make sure that it did what we think it did when we ran the eGen command. When would you use this? For our purposes, not that often. So if you forget how to get the mode or are unsure whether your answer is correct by looking at the frequency distribution from the tabulate command, you can use this approach as a sneaky way to get the mode for the data set without having, or to double check your work, right? By looking up here at the tabulate command and then making sure by asking for the mode. Why doesn't Stata just give you a mode using the tab stat command? I don't know. We don't really use the mode that often. And to be honest, I had no idea that you couldn't just call up the mode because I've never tried it. But now we know, now we both know. So what have we covered in this tutorial? How to get the 3 measures of central tendency, the mean, the median, and the mode, and how to do that within Stata, and creating an index variable in Stata, which is a variable that sums up multiple other variables using the eGen and row total commands here. All right, thank you so much for your attention today, and we will see you in class. Have a good one.